All right, hello everybody. Welcome to practice problem number 1 here. So I'm looking at lecture 1, and in this video here what I want to do is work out this problem that's in the notes here, trying to find this optimal amount of capital for the firm to borrow. So this is sort of building off what is covered in the lecture notes, and this is just one more example that I encourage you to give a try first, hopefully before you watch the video, and then you kind of see how you did and compare it to what I did. So this is kind of what I'm going to work with these problems. Fairly simple setup here, just my simple doc cam, and have some black pen and purple pen and a little piece of paper, but I think this will work. And as you go through the notes week by week, there'll be problems like this, and I'll embed these videos in these notes, and you can use these videos to sort of practice problems on your own and see what I'm doing and so on. All right, so let's get into it here. So problem 1 is a case where there's a revenue function that's given. So what we have in mind in this example is we're looking at how sort of money moves from financial markets to these net borrowers. In this case, we have in mind this firm who is trying to get money, which we're keeping track of with this variable x. So they're going to be borrowing funds. Sometimes when they borrow funds to invest in their business, it gets referred to as capital. But simply what we're just talking about is money. So x is representing money. And the revenue here is just telling me how much money or how much revenue is generated by investing this capital in the firm. And so the function that's given here in the notes is just that r is 4.9 times, what does that say, x to the power 1/2, or 0.5. We can write that exponent either way. And then it also says, what does it say? We have this 33% interest rate, so that looks kind of steep, but that doesn't matter. What I'm going to do here is then try to figure out how much money the firm should borrow when they face this 33% interest rate. So the idea is every time I take out $1 from the financial markets to invest in my firm to generate revenue, I'm going to have to repay the loan back. So in this case, what they're saying is that there's an interest rate that I'm quoted on the loan. And so to convert this into decimal, this would just move that decimal point 2 times to the left here, right? And I have an interest rate of 0.33, which is equivalent to a 33% interest rate. What that means is, as we were talking about in the notes as well, is that when you take out a loan of, say, X dollars, I need to repay that back to the bank. And of course, as we all know, perhaps from our own borrowing experiences, when the bank or the credit card gives you a loan, you have to pay back not only the principal amount you borrowed, X, but also interest. So that's how they make money, right? So what I'm going to do is I'm going to multiply X by this factor 1 plus I. Okay, this is 1 plus interest. So if I distribute that, what I'm essentially paying back is X, and I'm paying back X times I. So that interest rate here, right, would just be that 0.33. So 1 plus 0.33 would give me 1.33. So that'll be my loan repayment. Like, for example, if I just borrow $1, so if I take out a loan of only $1, and again, my intention with this money is to put into my business to generate revenue by selling things or providing services to consumers. That doesn't matter, right? All that matters is I have the revenue that I'm being generated from whatever business I'm doing. That dollar that I borrow is going to obligate me to make a repayment. If I plug that in, right, I have 1 for X times 1.33. So I'm going to have to pay back the bank principal and interest, which in this case on $1 is simply $1.33. That's true for every dollar I borrow. So what I'm going to do here with the marginal analysis that we were talking about with these problems is now figure out how much money should I indeed borrow. And so the way this works with marginal analysis is what I'm going to do is do this sort of one step at a time, where dollar by dollar, I decide whether it's worth borrowing the money and investing in my business to generate revenue. The general rule will be is that as long as that dollar bumps up my revenue more than 1.33, it's in my interest to borrow it. Okay, so to start this problem, what I'm going to need is a sense of, for my marginal analysis, is what these revenue numbers look like. So let me make a table here real quick where I keep track of my X, and then I keep track of my my revenue figures, and then we're also going to keep track of my marginal revenue, which I'll talk about here in 1 second. This is very straightforward. All you need is the revenue function that's given in a homework or a practice problem, and then you need a calculator, something like this. All right, so what I can do is just plug in some values for X. Usually when we're tackling these problems on homework or whatnot, I'm just going to need, say, the first like 3, 4, 5 possibilities, and one of these will be the right answer. Usually on the homework itself, there's multiple choice questions, so you're just kind of looking at what options are in front of you. All right, so I'm going to take a few of these, like X is 0, maybe 1, 2, 3, 4. We'll actually see how many we need as we go through the problem. All right, so for each X, now I just need revenue. All that amounts to is plugging into the function, and that's telling me how much I get. So clearly, if I take X of 0, and I plug that 0 in there, that just becomes 0, 4.9 times 0, so that's easy. If I put in X of 1, 1 to the power 1/2, that, if you put that in the calculator, that's just 1. So that just becomes 1 times 4.9. Okay, so in case people are perplexed by what's going on here as far as this story, it does seem like a miracle, right? But this is the College of Business. What do you do in the College of Business? You take $1, that's what this firm does, and you turn it into $4.9. If you can do that, then you can potentially make money, right? So that's what the firm's doing. How do they do that? It doesn't matter, right? That's just, there's some sort of story here, right? You make a product with the dollar, everybody loves your product, and then you go sell it at high prices and you make this kind of money, right? And so the idea here is this revenue that's being generated is going to be the source of some profit, hopefully, for the firm. All right, so let's keep going through a few more of these. When X is 2, so all I'm going to do here is plug 2 in here. So I need to take the square root of 2, which I don't know what that is. So let me use my calculator, and then multiply that by 4.9. And it looks like if I did that right, I got on the round, so 6 point, what does that say? 93, I think. You guys can check this. Let's do one more. 3. If X is 3, so I take 3, take the square root, and multiply that by 4.9, and I have, what does this say? 8.49. If I round that hundreds place. If I put in 4, the square root of 4, 4 to the power 1/2 is 2. I know that one. 2 times 4.9, let's see what that is. 2 times 4.9 is like 9.8, right? And of course, you can keep going. The idea here is what you're noticing, right, is as the firm borrows more money and invests it in the company, so X goes up, they generate higher revenue. No surprise, right? You put more money into the business, develop more product, and so on, your revenue goes up. Okay, so what I want to do here, though, and this is where that marginal analysis kicks in. So this is a tool that we can use to solve this problem of how much X to borrow. This is perhaps something you looked at in your Principles of Micro class, where they're looking at the margin. Does it make sense to say take another unit or not? All right, so this is going to be a change in revenue. Break out my purple pen now. So what I'm going to do is say, I don't need the first one because there's no change, but if I go from 0 to 1, I want to know what the change in revenue is, that's all. So when you borrow $1 of capital, and you put it into the revenue function, revenue climbs from 0 to 4.9. So the difference, right, when I climb from 0 to 4.9 is just 4.9. What I'm doing formally, right, is 4.9 minus 0, and that's the difference. All right, so the way I would say that properly is the marginal revenue generated by the firm from the first $1 of capital is $4.9. All right, let's do the second one. What does the second $1 generate? So again, this is going to be what sort of revenue jump do I experience if I plug a second $1 now into my firm? So to calculate that, right, the straightforward is I just take 6.93 and subtract 4.9. So 6.93 minus 4.9, and I get 2.03. All right, so that's my marginal revenue. Do the next one, 8.49 minus 6.93, and I'm getting marginal revenue here of 1.56. And then I'm going to do the next one, 9.8. So 9.8 minus 8.49 is 1.31. Okay, so again, the way I'm reading is that fourth, say, dollar of capital, for example, if you put it in the firm, when you already have 3 in, your revenue goes up by $1.31. Okay, so at this point, we have pretty much everything we need, so we're ready to solve this. What do I do? So here's my rule. As long as that marginal revenue that I'm being generated is greater than or equal to the cost of borrowing money, which in this case is 1.33. Of course, it always depends on what I is. If I changes, the cost of borrowing changes. This firm, right, is paying pretty high interest rate, 33%. So if you get a lower interest rate, things will change. All right, so what do? All I do here is just figure out now how many units of X will marginal revenue be greater than 1.33? All right, so you can start with, should I say at least invest 1? Well, if you invest $1, the marginal revenue generated by your company is $4.9. If you borrow that dollar from the bank, you have to pay back 1.33. Clearly, 4.9 is greater than 1.33, so you should at least borrow $1. The idea is, after you pay the bank back, you're still left with a lot of money, 4.9 minus 1.33. Where does that difference go? That's profit, right? That goes into your pocket. That's the whole reason for going into business. All right, same thing for the second. 2.03 covers the cost of borrowing. Same for the third, but not for the fourth. So what that means here is this is my optimal choice for X. I go up to $3, borrow $3. So what I'm going to do is say the optimal amount to borrow is $3. If I was to borrow a fourth dollar, my revenue would go up, which at first is desirable or looks attractive. But you have to keep in mind that fourth dollar generates me additional revenue of only 1.31, but the bank has to be repaid 1.33. So there's no point in borrowing that additional dollar. So the way this is working, the intuition is that your marginal revenue is talking about how much your revenue is going up by. And you can see that, although it's positive, meaning revenue's climbing, the marginal revenue numbers are getting smaller. That just means the jump in revenue as we go from dollar to dollar is starting to decline. So eventually it's going to decline below the cost of borrowing, and that's when I should stop asking for money. Okay, so I would say the optimal choice for the firm here is to pick out $3. Clearly, if the interest rate changes, this could change. So in the financial markets, if the interest rates go down for some reason below 0.33, perhaps then what we'll find is that the firm, when they redo this analysis, now it's more attractive to borrow money. Right? You tend to see that in the macroeconomy. When interest rates decline, companies and corporations tend to borrow more funds. So the decisions by these actors, like companies and corporations, are being partially steered by the interest rates and the various prices they see in the financial markets. These send signals, and then these firms respond. Okay, so that's good for that one.